So in 3-2, we talk about slope. In Math 7, we don't do slope. We only do the constant. But isn't the constant the same as the slope, really?
Yeah.
Yeah, it's how it's changing over time. So the slope is the steepness of a straight line. It's the ratio of rise to run. The steepness, and it's the ratio of rise to run. You guys have heard rise over run, I think, before?
Yes.
Yep. It's coming back around. So we have the steepness, like a mountain, you know, when you climb a mountain or something. And then you have the rise over run stuff. Again, it's a ratio. Your slope is always fraction. It's just that sometimes 1 is in the denominator. So if 1 is in the denominator, then you don't have to write it. But you have to know it's there.
You're so short next to him. Oh, I'm sorry.
Okay, and then we have this information that's important. We have this rise over run.
That's up on the wall, yeah.
Uh-huh.
Yeah, I know.
We have the vertical change and the horizontal change. Vertical is the y, horizontal is the x.
This video's ruined.
So we have the delta sign, which means change. That triangle means change. It's delta, change. So remember, rise is vertical, run is horizontal, y is vertical, x is horizontal, like on our axis.
Oh, we are
Okay.
learning this kind of in science.
Yes, you did this in science recently.
Yeah.
And again, if you want to write down what the triangle means, it means delta in Greek, and that means change or difference. Difference is kind of a key word, right? Difference means subtract in math. Subtract. Just like you were doing in the tables and charts, you were kind of subtracting to see what the difference was. So that's delta. Here's an example for you. A hiking trail rises to 6 feet for every horizontal change of 100 feet. What is the slope? So it's rising up 6 feet, going up for every 100 feet this way. So it's rise over run. Rise 6 feet over run 100 feet.
Oh, these are like ward problems all
Yes.
the time.
No, not all the time. Half the time, probably. But that's really not too challenging. Rise, it has the rise in there. 6 over 100, you guys know, is what?
What?
Oh, 49.
3 over 50. 6 over 100 is the same as 3 over 50. So you do have to simplify it. Okay. Now, we don't normally put these in decimals. We don't normally, unless we're dealing with money or something like that, because this rate is much easier to graph if we have points. We have points there, right? We know it's changing 3 vertically for every 50 horizontally, and 3 would be our y, and 50 would be our x. So if we change it into a decimal, then we don't have our x and y anymore, do we? Okay? So we leave them as fractions. So those of you who get like so excited to change everything to decimals from fractions, don't do that anymore. Okay? Leave them alone. The answer gives us a lot of information, because not only will we be solving, but then we're going to go back and graph what we solved. So we'd like to keep these answers in the forms of x's and y's. All right, here's another example. Sometimes you're given a graph. You're given a graph, and you don't have to write this one down,
No, thank you.
because I'm going to show you a better way. So if you don't want to write this example, that's fine if you want to, but some of you might want to write the information on the bottom of the page because that helps you. There's like key words, so like in a word problem, if it says it's going up, it's going to be positive. If it's going down, it's going to be negative. If it's going to the right, it's positive. To the left is negative. Those are just like key words for word problems. So if you don't want to write, if you don't want to draw the graph, that's fine because I'm going to show you a little bit better way in a minute. But if you want to, you can. It's up to you. It's also in your book. So if we're given points on a graph, we can solve this algebraically. We just have to realize what our y is and our x is and do some subtracting and dividing. But there's a much easier way to do this stuff. So I'm going to show you that now. You ready for the tricks? I know you like the easy math, right? I'll wait. Is that okay right there? You guys are just writing down the bottom stuff now? Okay, so if you're given a graph, but you're going to see this in the practice and the homework, and let's say you're just given like 2 points on a graph. Say this one, and we'll go with that one. 2 points, okay? Those are coordinates. They're listed as x comma y, right? But I can put in the values, right? I can count. This is x, remember? And this is y. So I can go 1, 2, 3, 4, 1, 2, 3, 4, 5. Remember this? 4 comma 5. To get that point, let's see, this is 4, so 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this was 8 comma 9. So now if I want to get the slope, I could do some algebra, or I could do this magic trick. I could, let's draw the line first so you can see it better. I'm going to connect the points first. Okay? And then what I could do is, I know it's rise over run, right? So I could go 1, 2, 3, 4. That's my rise. 1, 2, 3, 4. See how the dots are connected now?
Yeah.
So this one is 4 over 4, right? Which is what? 1. And that happens to be my slope. Isn't that awesome? And then I'm done.
Is that it?
For that one, yeah. So instead of doing the algebra, I could just count the squares. But what if, well, we'll get there in a second. What if I want to, or I have a graph that's more like going down? Like that? Is it still rise over run? Yeah. So I'm going to go 1, 2. One, 2, 3, 4, 5.
Yeah.
Is it positive or negative?
Negative.
Negative, because look, I went down 2. Good? You like shortcuts? Counting squares? Any questions on that?
This was in science.
You did this in science, so you're all going to get an A.
Yay.
All right, let's go to the next page, and then we're almost done here. One more page. All right. So you guys, you can get these not in graphs but also in charts again, and I want to explain what's going on here. So if you get this in a chart or a table, this is how you do this. So what you do is you take your y's over your x's, okay? The difference of, remember the change is the difference. So let's say, let me see what I did down here. Okay, so let's say our y's are yellow here. So you can see I'm just going to pick these two. So that's 9 minus 12, and that makes a -3, right? So I just picked two of the y's. And then I can pick two of the x's, and they should be the ones right next to it. So that's 3 minus 1, and that's 2. Do you see what I did there?
Why is it 3 minus 1?
It's 3 minus 1 because I did 9 minus 12. You have to go in the same order, right?
Well, can you do 9 minus 9? Oh, can you do 12 minus 9?
Yeah, you could do 12 minus 9 and 1 minus 3, but you get the same answer.
But then it wouldn't be a negative.
It'd be 3 over -2, which is the same as -3 over 2. The negative translates up and down.
Oh,
Cool? And if I want to check my work, then I could just pick the other two numbers, the 3 and the 6 and the 7 and the 5, and I should get the same answer. Okay? And what does this -3 over 2 represent? What is that number? What are we trying to find in this section here? What's the title of it?
Slope.
Slope. Good. So that's my slope. That's it right there. And it should work. If you did it right, it should work for the next two set of points as well. Okay? So here's the slope formula you learned in science. I don't know if you learned the M part of it, but that's the symbol for slope. It's the letter we use for slope. But this is the one you learned in science, right? Raise your hand if you saw this in science class, like a month ago, probably. The slope formula? You should have.
It's familiar. Like, I think I...
Okay,
Yeah,
check back in your...
So Peyton's classroom is right up in the top left corner.
See, he's seen this.
Right
Okay, so when you're calculating slope in science, you're using the same exact formula. It does not change. It's still the difference in y's over the difference in x's. What are these little 2's and 1's? Does anyone know? First one, second one, and they're just like little subscripts, so we know we can label our points. That's what they are. It doesn't really matter if you do y2 minus y1 first. You could do y1 minus y2, as long as on the top, if you start with the 1's, on the bottom you start with the 1's, okay? So if you start with the y1 minus y2, then you have to start with the x1 minus x2. You don't want to switch those around. And M is the symbol for slope because the word for slope in the Latin language starts with M. So we kept that. It would make a lot of sense to put an S, right? Equals S. But we kept the Latin word for slope. Don't ask me what it is. You know, I got an F in Latin, but, you know.
Can you, like,
What is
try to
it?
pronounce-
I don't know. I'll make it up. Should I make it up?
Yes.
It's melope.
Melope.
You could look at
Spell it.
You could look it up later. All right, but that's where the M comes from, okay? It's not just some random letter. It actually comes from the Latin. So here's what I do. When I'm doing this, I actually use highlighters because it really helps you to organize what you're doing. So if you're given a graph with different numbers, different values, then you could use a highlighter to organize it. Do you see how I organized it?
Yeah.
Okay?
All we have to do is find the slope, basically.
You're finding the slope.
Basically.
Now, if you're given a graph with points, wouldn't it just be easier to count the squares?
Yeah.
That's what I say. So if you're actually given a graph, I would count the squares if you can.
Well, what if you
Okay.
can't count the square?
If you can't, then at least you can fall back on the formula. But if you can count the squares, like sometimes you're going to get a portion or a half a square or something, if you're good with that, count the squares.
Can you go back up to the formula?
No, because you were on your phone.
Ooh.
So here's your y2 minus y1 over x2 minus x1. It's all color-coded when you're doing your homework, it's a good idea.
It's on YouTube.
It is. It is on YouTube.
So it's like
Oh.
So Tanner, make sure you're not on your phone in class. Okay.
I was on that one photo math app.
Mhm.
Taking pictures of the home.
Right.
I
So the last example for you guys. This is how you'll be given a problem generally to find slope. You're going to be given 2 points. They'll say point this and point that, point A and point B. In this case, this example, it's point R and point S. And I highlight the X's and Y's. And then I plug it into this formula. This y2 minus y1. So that's the 2 minus 3. And it doesn't matter if you go 3 minus 2 and negative 4 minus 1, as long as you go in the same order every time. So 2 minus 3 over 1. Why did I put these parentheses here? Why did I do that? Why, Benjamin?
That's what you use like for graphs.
No. This is 1 minus minus 4. Why would I use a parenthesis? Is it just for fun because I like writing extra things?
Yep.
No. Why would I do that? Why?
So that you can understand that the 4 is negative.
Good. See, I separated it, and she said so you can understand it. You can see it better, right?
Oh, she's so smart.
So that way you don't forget to put an extra negative, because what happens when you have 2 negatives there? What do you do when you have double negative? Add. Good. So that's how you get the negative 1 over the positive 5, because 1 double negative 4, right? 1 minus minus 4 is 5. Do you remember this from 7th grade? So when you have a double negative, it's a good strategy to use parentheses.
Your highlighter's so weird too.
It is. So if you have double negatives, use parentheses.
Is this the harder than the last unit or the last
Not the beginning of it, but then yes, towards the end, yes.
That is the hardest unit.